This is my second video in my module on finding probabilities in which there are very large numbers of possible outcomes. And so basically probabilities involving counting rules that we've encountered, such as the multiplication rule, combinations, permutations. And so I just want to run through three quick examples with us here, just common problems. So we say example number 3, let's take a look at it. We say a store has 6 TV graphic magazines, 8 news time magazines on the counter. It says if two customers purchase a magazine, it says find the probability that one of each magazine was purchased here. Okay, so let's write down a few rules here, starting with this. I think that number 1 should be this: is write down the probability. Write down the probability that we want to find. So the probability we're trying to find here is this. We say, if we were to sell 2 magazines, essentially, what is the probability that we have one of each? So 1 TV and 1 news time is what we're trying to find here. That being said, we say, okay, so now if I wanted to find this, we'd calculate first. So find the sample size. So we say find the sample space size. Okay, we need to know the number of total possible outcomes. Okay, the interesting thing about this is this. The sample space could be, drawn in, I guess it's like a Venn diagram-y kind of thing. We say there are 14 total magazines, and if we were to split this up, we say, well, the TV graphic, which was in the minority, we say TV graphic, there are 6 of those, and we say news time. We say news time, there are 8 of these for the 14 total. We say to find out how many possible ways exist to do this, we would say, well, we're selling 2 from a total of 14, okay, just in general, if 2 magazines are sold, how many ways exist to sell 2 magazines out of 14 total? And since order doesn't matter, we say 14 choose 2. So that being said, now we'll go to the specific event here, okay, so we say find the sample space size. We've done this. We say now find the event space size, the event that we're considering here, the event space size. So in order to do this, we actually go through a category at a time. And so essentially we're saying, okay, well, the event that we're considering here happens to be the event that we sell 1 of the TV and 1 of the news magazines. So we say of the 6 TV ones, how many do we want to sell here? In this case, we say 6. I want to choose 1. And then it says and. And then what? We say, well, of the 8 news ones, how many of those do we want to sell? Well, we want to choose 1 of those. Okay, so to go through this a little quickly on this video, you can get a calculator out, but we say 6 choose 1. If you had 6 things and there was choosing 1 at a time, how many ways exist to do this? We say 6 ways to do that. Of the 8 things here, we want to choose 1 magazine of those 8, so we say 8 ways to do that. And then we say 14 choose 2. I suppose we could look at on the calculator. We say 14 total items, choosing 2 at a time. There's 91 ways to do so. Okay, so we say out of 91. So it looks like we get 48 out of 91 probability here, and we do always need to find this as a decimal, at least to interpret what our results mean. We say 0.5275-ish, so about 0.5275-ish is a 52.75% chance. So about half of the time, you'd sell 1 of each, kind of theoretically speaking. All right, well, example 4 is a little bit different than example number 3 here. We say we have a combination lock that consists of 26 letters of the alphabet. Okay, so you got a combo lock. You can choose letters to set up your combination. But we say if a 3-letter combination is needed, find the probability that the combination will exist of the letters A, B, C in that order. Okay, so we say the same letter can be used more than once. It says keep in mind that a combination lock really is a permutation lock, and the reason why is because the order of its elements matters. That is, if I have a combination, here's my combination, A, B, C, then the combination B, A, C, even though it's the same 3 letters, it wouldn't work. So order matters here. Okay, so now we'll go through our instructions we wrote up top. We say, number 1, write down the probability. So we say the probability A, B, C, maybe I write a little note to myself here, in order. So we say, all right, well, first of all, let's calculate the sample space. So we say the sample space, it represents the total number of ways we could set up a 3-letter combination to begin with. So if you think about this, a 3-letter combination where we can repeat letters, we could say, well, here's our first letter, second letter, third letter. We'll use our multiplication rule on this one. We say, well, for the first letter, we got 26 options to choose from. And we could actually repeat the options. So we say, well, 26 here and 26 here. The total number of possible ways to do this is actually just 26 cubed. So our denominator becomes 26 cubed down here. We didn't even have to use a combination. We could just use multiplication rule. So now we say, all right, well, now let's look at the event. We've calculated the sample space size. Let's find the event space. The event is we get A, B, C in this order. And, to my recollection here, there's only one way to get A, B, and C is the letter A has to go here, the letter B has to go here, and the letter C has to go here. So essentially, there's only one choice for each of these three spots. So the top here just comes out to be 1. So we could calculate this. We could say, all right, 26 cubed is 17576. If we say 1 divided by 17576, we get about 4 zeros and then 5690. So we get about 0.0000569-ish decimal, or this would be like as a percentage. We could say 0.00569%. So it's a very small chance that you're going to get A, B, C in that order if it's a 3-letter combination, which is good. I mean, this just means that people aren't going to pick your luck. Hopefully, or not pick it, but figure it out. So let's look at this last one down here. We say, all right, there are 8 married couples in a tennis club. If one man and one woman are selected at random to play in the summer tournament, find the probability that they're married to each other. So we say, all right, well, this is multiplication rule again. The reason why is because we're selecting a man and we're selecting a woman. Okay, so we say, let's write down the probability we want to find. We say probability that they're married. The two married couple. The two that we choose are a married couple. Okay? We say, well, the number of possible ways to do this is us calculating our sample space size. How many different ways exist to choose, say, a man and a woman in the first place? We say, well, we have eight total married couples. So of the 8 men, we want to choose 1 man. And of the 8 women, we want to choose 1 woman. Or we could just say this: there are eight ways to choose a man and 8 ways to choose a woman. These are going to come out to be 8 anyways up here. So there are 64 different ways to choose a man and a woman couple pairing for the tennis club. But we say, well, what's the probability that they're married? Now, when you consider this, we have like couple A. We say A man, A woman, B, C, D, E, F, G, and H. If this were to be the same thing down here for the say man and woman here, and these are the married couples. We have couple H, couple G, whatever. We say man, woman. How likely is it that we get a match between one of these? And we say, well, it's just 1 when you think about it here, because it's one person matched with their spouse. Okay, so there's only one way to match them together, and that's just that they're actually matched together. Otherwise, they'd be jumbled up and they'd be matched with somebody they're not married to. So we get a 1 in 64 chance. We say 1 divided by 64. Let's go ahead and get our decimal on this one. So about a 0.015625. So about a 0.015625 is a decimal, or as a percentage. We say there's about a, whoops, let me get rid of this here. I get so used to writing decimals. As a percentage, we say there's a 1.5625% chance of this happening. So not very good, actually. So anyways, just counting rules and probabilities. Just make sure you write out your probability first, and then find your sample space size and then your event space size using the appropriate rules. Cheers.